Okay, this is lesson 10.3, triangles. A line segment is part of a line containing two endpoints and all of the points between them. So in this picture over here, for example, there's a line segment from point A to point B. A triangle is formed by three line segments that intersect only at their endpoints. So you see our triangle here formed by segment AB, segment BC, and segment AC. A vertex is the point where the segments of a triangle intersect. So for example, this point right here at B is a vertex. Each of the lines that make a triangle is a side. So this is an example of a side. And each of the angles formed at each of the vertices, the triangle has three angles. So this is an example of an angle. Okay, so there's a property that angles of a triangle have. The sum of the measures of the angles of a triangle is 180 degrees. So no matter what type of triangle it is, all three angles will add to 180 degrees. So in this picture, x plus y plus z equals 180. So let's use that to solve a couple problems. So example 1 says find the value of x in triangle DEF. Okay. And in this triangle, and in every triangle, all three angles add to 180. So we can write an equation that shows that 43 plus 52 plus x equals 180. And we know how to solve equations, so we will go ahead and combine like terms here. 43 and 52 is 95 plus x equals 180, and then subtract 95 from both sides. I get x is equal to 85. So since x is 85, we could also say that the measure of angle F is equal to 85 degrees. So that is what this means. This little m means measure, and then this is the symbol for angle. So the measure of angle F equals 85 degrees. Okay. So go ahead and pause the video and do the same sort of thing on the first try it yourself problem, and then press play when you're done. Okay, for this one you should have gotten that x is 102 degrees. Okay, for the next one it says the measures of the angles of a triangle are in the ratio 1 to 3 to 6. What are the measures of the angles? Okay, so it's been a while since we've looked at ratios, but when you have things that are in ratio, that means that each of these numbers is going to be multiplied by the same number to get whatever the actual measures of the angles are. So basically we can take this and represent each of the three angles with x, 3x, and 6x. This is 1 times x, 3 times x, 6 times x. Whatever the angles actually measure, it's each of these numbers times the same number. And then, since we know that the three angles add up to 180, we can write an equation that shows that x plus 3x plus 6x equals 180. And now we just solve this. So we'll combine like terms over here. This is 1 and 3 is 4 and 6 more is 10 x. And then divide both sides by 10. Here x is equal to 18. Now this doesn't answer the question. We're supposed to find the measures of the angles. So we go back to our three expressions here. So one of them is just x, which is 18. We have 3x, which is 3 times 18, or 54. And then 6x, or 6 times 18, which is 108. So the measures of the angles are 18 degrees, 54 degrees, and 108 degrees. And we could always double check this by making sure that these three add up to 180, which they do. Okay, so there's a similar problem for try it yourself number 2. Go ahead and pause the video and work through that problem, and when you're finished, press play to check your answer. Okay, for these angles, you should have gotten 36 degrees, 54 degrees, and 90 degrees. Okay. Angles can be classified by their degree measure. Acute angles measure between 0 degrees and 90 degrees. Obtuse angles measure between 90 degrees and 180 degrees. Right angles measure exactly 90 degrees, and straight angles measure exactly 180 degrees. Alright, so we'll use this information about angles to then classify triangles. So one way we can classify triangles is by their angles. So an acute triangle would have all 3 acute angles. An obtuse triangle would have 1 obtuse angle, and the other 2 would be acute. And a right triangle would have 1 right angle with 2 acute angles. So this is one way to classify triangles, is by their angles. Another way to classify triangles is by their sides. And congruent sides are sides that have the same length. And that's how we classify triangles, by their sides, is by talking about how many different sides have the same length. So we see our 3 types of triangles classified by sides this time. So a scalene triangle is one that has no congruent sides. These are all different lengths. An isosceles triangle has at least 2 congruent sides. And an equilateral triangle has all sides congruent. Okay, so for example 3, we want to classify each triangle by its angles and by its sides. So we'll have 2 different names for each of these triangles. So for the first one, to classify it by its angles, we look at the angle measures. We have 35, 35, and 110. Well, we don't have all acute angles because 110 degrees is not acute. We do, however, have 1 obtuse angle because 110 degrees is bigger than 90. So since this angle is obtuse, we would say that this triangle is obtuse. Now to classify it by its sides, we want to ignore the angle measures and look at the markings on the sides. And we see these 2 marks here showing that 2 of the sides are congruent. And here we see an isosceles triangle has at least 2 sides congruent. So we would say that this is an obtuse isosceles triangle. So this is classified by its angles because it has 1 obtuse angle, and this is classified by the sides because it has 2 congruent sides. Okay, let's look at B. So here we only have 2 angles marked and we're missing the third one. So before we can really classify this, we want to make sure we know what the measure of this angle is. Well, we know that all 3 angles add up to 180 degrees. So let's call this one X for just a minute. And we know that 49 plus 64 plus X is equal to 180. So let's go ahead and combine like terms here. That's 113 plus X equals 180. And then subtract 113. Get 67. So now we know that this angle measures 67 degrees. Now we can classify the triangle first by its angles. So 49, 64, and 67. All of those are acute angles. They're all less than 90 degrees. So this is an acute triangle. Okay, now to classify by its sides. Well, we don't have any side measures that are marked as congruent. And if you notice, we have all different angle measures, which means that we have to have also all different side lengths. So that is a scalene triangle, no congruent sides. So this is an acute scalene triangle. So go ahead and work through try it yourself number 3, classify each triangle by its angles and by its sides. When you're ready to check your answers, press play. This first one is an acute equilateral triangle. And this one is an obtuse isosceles triangle. Okay, let's move on to section 10.4, the Pythagorean theorem. In a right triangle, so this section is focused entirely on right triangles. The sides adjacent to the right angle are called the legs, and you see that in this picture. Here's the right angle, and the two sides that are next to that right angle are the legs, the two sides that form the right angle. The side opposite the right angle is called the hypotenuse. It's the longest side of a right triangle. Because it's opposite the biggest angle, it will be the longest side. So in words, the Pythagorean theorem says if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Which sounds very confusing, but in symbols, that just says that a squared plus b squared is equal to c squared. So a squared plus b squared is equal to c squared. So if I square the two legs and add them together, it's equal to what you get when you square the hypotenuse. And we use this to find missing side lengths in right triangles. So example 1 says to find the length of the hypotenuse of the right triangle. Okay, so the very first thing before you use Pythagorean theorem, the very first thing that you need to do is first make sure that you have a right triangle, which we do. Here's the right angle. And then once you've identified the right angle, we need to make sure we know which sides are the legs and which one is the hypotenuse. So there's two ways to do this. One is to look at what sides form the right angle. Those will be the legs. The other way is to go straight across the triangle to find where the hypotenuse is. So here's the right angle. Right across from it, this is the hypotenuse. So in Pythagorean theorem, the C is always the hypotenuse, and that's how that's labeled here, which is good. The other two legs, because we're going to add the two squares together, a squared plus b squared is the same as b squared plus a squared. It doesn't matter which one of these is a or b. So let's call this one a and that one b. Again, it does not matter. So we'll start with a squared plus b squared equals c squared. And we just want to substitute the lengths that we have. So a is 20, b is 15, and c is something we don't know, so we'll leave that as c squared. And now we just want to figure out what c is. So let's go ahead and square these. Following our order of operations, we want to evaluate the exponent first and then add. So 20 squared is 400, 15 squared is 225. Alright, and then we'll go ahead and do this addition. 400 and 225 is 625. And then just like we did in section 10.2, in order to solve this for c, we want to take the square root of both sides. So that we get just c on this side, since the square root and squared are opposites, or inverse operations. And then we always want the positive or negative square root of this number, which when we take the square root of 625, that comes out to 25. And then we think about what this problem is talking about, and since we're talking about the length of a hypotenuse of a right triangle, negative 25 makes no sense at all. So we're going to throw out that negative solution, and the length of the hypotenuse is just 25. Okay. There's a try-it-yourself problem for you to work through. It's going to be using Pythagorean theorem also. So go ahead and pause the video, work through that problem, and when you're ready to check your answer, press play. for this one, we should have gotten 29 feet for the hypotenuse of the right triangle. Okay. If you know the lengths of two sides of a right triangle, you can use the Pythagorean theorem to find the length of the third side. And it doesn't matter if you're missing the length of a leg or of the hypotenuse. Any two sides will allow you to find the third side. So this process of finding the length of the third side, this is called solving a right triangle. Okay, and we'll see that in example 2. So example 2 says a 15-foot ladder is leaning against a house. The base of the ladder is 3.5 feet from the house. About how many feet does the ladder reach on the side of the house? Okay, so we're going to want to draw a picture here so that we can just kind of see what this looks like. So we have a ladder that's leaning up against a house. So let's first start with just a basic rectangle to represent the house. From there, we have a ladder that's leaning up against it. And then if we connect this side to the base of the ladder, that's where our right triangle comes from. So this is the ladder, this is the house. So now let's fill in the information that we know from the problem. It says a 15-foot ladder. Well, that's the height of the ladder. So if this is the ladder, when it's leaning up against the house, here's the bottom, here's the top. This whole side is 15 feet. It's leaning against a house. The base of the ladder, that's the bottom, is 3.5 feet from the house. So this distance here from the base of the ladder to the house is 3.5 feet. About how many feet does the ladder reach on the side of the house? Okay, here's the side of the house. We want to know how many feet does the ladder reach. So this is the side we're looking for. Okay, now again, it's very important that we know where the right angle is, and that would be right here, where the horizontal line here and the vertical line there meet. Okay, now we have two sides of the triangle, and we're looking for the third, so we can definitely use Pythagorean theorem. But remember, we need to make sure we know which one is the hypotenuse, or the c, in that equation. So here's our right angle, go straight across the triangle, and that will be c. And remember, it doesn't matter which of these is a and which one is b, so let's call this one a, and that one b. We have a squared plus b squared equals c squared. A squared, let's see, a is 3.5, so this is 3.5 squared. B we don't know, so we'll just leave that as b squared. And then c is 15, so this is 15 squared. Okay, 3.5 squared, if you do that on the calculator, you should get 12.25 plus b squared equals, and then 15 squared is 225. Alright, now to solve for b squared, since this is addition and this is positive, we'll subtract 12.25. We'll get b squared is equal to 212.75. And remember, when we just want b and we have b squared, what we want to do is take the square root of both sides. So we'll end up with just b is equal to positive or negative, and we take the square root of 212.75, and it's approximately 14.6. Now again, because we're talking about an actual height on the building, or on the house, it can't be negative, so when we answer the question, we take just the positive solution here, and we say that it will reach 14.6 feet. About 14.6 feet. Okay, There's a try it yourself problem on the back of the page. So go ahead and pause the video and work through that problem and press play when you're ready to check your answers. Okay, the width of the garden, you should have gotten about 21.2 feet. Okay, there's one other thing that Pythagorean theorem is useful for. The Pythagorean theorem is written in if-then form. So if a triangle is a right triangle, then a squared plus b squared equals c squared. If you reverse the statements after if and then, you form the converse of the Pythagorean theorem. So notice the only thing that's been changed from the Pythagorean theorem to its converse is that this portion here has been switched with this portion. So instead of if a triangle is a right triangle, we have if a squared plus b squared equals c squared. Then a triangle is a right triangle. So this is saying something a little bit different. It's saying that if you know that the sides have this relationship, then you know that that triangle is a right triangle. So it's basically going backwards with the Pythagorean theorem. It's not assuming that you have a right triangle and then using that to find something out about the sides. It's now using what you know about the sides to determine if something is a right triangle. So since the converse of the Pythagorean theorem is true, you can use it to determine whether a triangle is a right triangle. Okay, so let's see how that's done. Example 3 says the measures of 3 sides of a triangle are given. Determine whether each triangle is a right triangle. Okay, so just like we would do when we have a figure, we need to identify what the c, or the hypotenuse, would be in these 3 sides. Well, since the hypotenuse is always the longest side, 8, 9, 12, 12 is bigger, we'll call this c. Now it doesn't matter which one of these we use as a or b, let's just call 8a and 9b. So we want to see if a squared plus b squared is equal to c squared. If it's a right triangle, that will be true. If this is not true, then it's not a right triangle. So let's plug in 8 for a, 9 for b. We want to see if that's equal to what we get when we plug in 12 for c. Alright, 8 squared is 64, 9 squared is 81, 12 squared is 144. And let's go ahead and add these. 64 and 81 is 145. And is 145 equal to 144? No. So this is not a right triangle. Okay. Let's do the same thing on B. Now again, identify what A, B, and C are. So the biggest side is 25, that's C. And these two, let's call 15A and 20B. So A squared plus B squared equals C squared. A is 15, B is 20, C is 25. 15 squared is 225, 20 squared is 400, and 25 squared is 625. Oh yeah, we want a question mark on these because we're trying to determine if they're equal. We're not saying that they are. 225 and 400 is 625. And we want to know if that's equal to 625. Well, yes it is. So we would say that this is a right triangle. Okay. So for the try it yourself problems, you're going to do the same thing. Pause the video, work through those 2 problems, and when you're ready to check your answers, you can hit play. Okay, this first one is not a right triangle. But the second one is a right triangle.